Hello guys, so welcome back to our channel, and in this video we're going to make a substitute interface for a Arduino relay. Okay, so this relay is 12 volts. Okay, so but Arduinos that we have um, is commonly in 5 volts, and when you plug this in, this relay is not working for some reasons, so I need to build one. Okay, so since it's a relay, I need another relay, and I'm gonna copy the design. Okay, so I think there is a transistor right here. So I have a transistor which is a NPN transistor. This is BC547, and then there's a resistor right there. You can choose the value of the resistor, but for safety purposes, I use 1 kilo ohm for this demonstration, and you will see that there is a diode here. So I'm gonna use the diode in order to protect the system or the Arduino system from the backflow of electricity when the relay comes off. All right, so and then you have the LDR or LED that will tell you that the relay is on, and it's right in here. So basically, that's all the component that we need, and then we can start building. Okay. So basically, this relay will be triggered by the signal coming from the Arduino. Okay. So I'm gonna use the NPN transistor to um, as a switch, so that when that signal, positive signal, is on, the the entire system would be closed, and then there will be a flow of 12 volts going into this relay, and then this relay will turn on. All right, so basically, we do not want to hurt the Arduino, so we'll build the resistor before it. We do not want to hurt both of them, so um, the resistor will regulate the current passing through and coming into the transistor. Okay, likewise, if there's a backflow from the relay, the resistor will um, prevent that from directly passing through and coming in contact and interacting with the Arduino. But yes, and then uh, there will be a large amount of current and voltage that will pass through the transistor when the system is on. So the emitter should have some resistor, and then that would flow to the diode, and then goes back to the negative pin of your Arduino. So that's for signal processing. Okay, so how do you know that this will work? Basically, we'll simulate the signal using multimeter. All right, so I'm gonna apply some positive voltage in the base, and then you will see that the diode lights on. So there is a flow of current, and then the circuit is successful. All right, so next is the load side. Okay, the load side. Okay, since this will require us to use another source, external source, we'll make sure that the source will not interfere and interact with your Arduino. So I'm gonna put a diode, and then um, yeah, so I'm gonna put it here, and then we're going to simulate this system using um, 9 volts battery, or you may wish to uh, uh, put the relay. Okay, I'm not going to put the relay just yet because of the pins. The pins are difficult to uh, put in the breadboard. All right, so there's a positive input here, and then there's a negative input at the end of the diode, but you will see that there's no light coming off because the circuit is not connected yet, because the positive input to the base will uh, be the switch to make the system on or close the circuit. So we apply it here, and you will see that it lights off, lights on. I mean, okay. So that's it. Then you can regulate how um, how much current will flow back, okay, by changing this resistor. Okay, so um, you can start. I think the safest is 220, then going above. Okay, the threshold. So that's it, and we're gonna build the circuit in the breadboard or in the pre drilled PCB. Okay, so we'll start with the relay, I guess, because it's the biggest component and will take much space. And you will see that our relay is takes a lot of space. All right, and yeah. So I need to drill some holes just to make it fit. So I will need I'll need this. You just have to mark it properly. So make sure that it's properly marked. Excuse me. Yeah. Alright, so we had to change it. Um. Anyways, there's a lot of that in the market. Okay. Let's go. There you go. Um, now we will check this. Okay. Problem with me is I can't remember properly. watts. Okay. There we go. Okay, we go. So, just need one more. Yeah. Okay. There we go. Okay, okay, okay. It's not looking good. Need to drill. Yeah, that challenge with this board is you have to adjust the holes because they are scaled but not perfectly fitting to the parts. Okay, so you see there it fits. Okay, so you just have to solder it right now and be careful because there are some components that have fragile attitude, easily breaks. This attitude, they have the fragile attitude. You don't have um let's get this right. Okay, there you go. And then the relay, you have to choose whether which is positive, which is um, this one will be the positive, And then this will be the one connected to the transistor. So this will be the foot of the, so that's the foot. So put it here. So you see, there you go. All right, there we go. So to check, uh-huh, this one will be positive. Yeah, that's good. Then you have to bend it over. Yep, bend it over, and then uh, that's gonna be the transistor. Okay, the transistor should, you have a choice. You have a choice. So this will, by my choice. Yep, there you go. Yeah. Alright, and this will be connected to one another, so you can bend it over. And there you go. Then you can start soldering up to this point. Okay. So I guess we'll power the soldering iron. There's the soldering iron. And then while waiting, you can actually, I think, let's just put it here. While waiting, we can now put other components. One goes to the base of the, um, yeah, one goes to the base, and that's gonna be the input. So you can actually get the resistor as easy as that. Right there. And your circuit is looking nice. Then solder it later here. And um you can, this one is for the negative port. Let's decide the value of the resistor later. So I might be able to change this. Okay. Yeah. So these are the pinouts of your relay. All right, I think the iron is hot enough. Mm, So we will use this. Oh, then if you have problems with your respiratory tract, I advise that you are going to wear a mask when soldering. That might irritate your lungs or your respiratory tract, so I advise you go as far away as possible. Okay, because and then if you have family members that has a respiratory condition which is irritated to this one, I advise you to advise them to go as far as possible just for this moment. Just for this, there it is, soldered. And we also soldered the it takes time. It's really difficult to perfect, but practicing and practicing over and over again will help you uh, develop the skill and the workarounds in order to make things work. So, especially when it comes to electronics, skills builds over time. So it depends on your willingness to learn and amount of time you spend in doing projects. So all of it, or most of it, is soldered. Then all that's left is to cut the excess. Okay, so we're going to cut the excess. You can use a plier for this or a nipper. And there are special tools out there you can buy if you want to. Okay, or a nail cutter. But definitely you're gonna lose your nail cutter afterwards. Alright, there you go. And then um, you may wish to change the value of the resistor. So I think I may need my resistor set. Alright, so and find a value that it's not too high, not too low. You can choose a potentiometer to find that value. So you have to learn how to read the resistor value using color-coded combination. Okay, there are a lot of material or tutorials how you do that, but the easiest thing is to have a multimeter with you. Just connect the ends of your resistor and it will read the value for you. So I'm looking like for 320 ohms or 220 ohms. I think that should do it for 1/2 watt. And the wattage depends on the wattage of your relay because it will consume voltage and the leftover will be consumed by your resistor. And 1/2 watt means zero point 0.5 amperes per unit time. Okay, and 320 hours. So there's a computation. I'm not going to discuss that in this video. Basically, hopefully in other videos. So that's 220 and you can choose that. Uh-huh. Pre-weds. This is 220 but this is larger. Um, this one. Give me this one. Yep, 330. I think this one will do. Okay, since the relay will consume. Okay, so I think there will be a less leftover. So I think 220 will do. Okay, so we're going to connect it in our output, which is this one. Yeah, there you go. So I'm not sure if that this will be enough, but hopefully all is well. Uh, all right, so I think there's much space. I still have to put um, the diode, so I think I have to, yeah, make it this way. That will do. This will do. And the diode is should go here. You can adjust, or we can adjust if we want to. There you go. Yep. And solder the parts. Okay, solder the parts. Okay, and then this one will be the input. So coming from the relay or from the Arduino. There you go. So basically, takes a while before you finish the project. Depends on your skills. Depends on your the availability of resources. Mm. So if you have them all, still you have to issue a lot of time in preparation. You just have to make sure that everything is working before you solder them in the rightful places. Because if you're not going to do that, I think you'll be wasting resources. So you have to check from the schematic diagram, from the concept. Then after that, after that you're gonna get that. You have to check over and over again. And after this, you're not yet 100% sure. Still have to check if it's working or not. Okay. So there's a lot. Okay. So Shopee Master is attacking the town. One more lead to go, and I think we can test it. Hopefully, things will work as the way we expected. Add instrument. Yeah. So, um, for beginners, this will help you by there's a lot of holes in it, and then you don't have to mail the PCB. You just have to place the parts, and then there you go, add some connections, and then it will do. But you will notice that this is not practical in the long run, because you still have to design your own circuit, and then you're gonna do that. Okay. But for the meantime, if you are going to um, make small project, this board is helpful. So I want to solder it to fix. It's fine. Then the inputs. Okay, basically you have two inputs. This one is for the um, external power supply. Okay, so this is for the external power supply. Oh, you can check. You can use connecting wires for that. And we need two of them, positive, negative, and then um, this is not shown in the diagram. Oh, what happened to you, my friend? So this is actually my first tutorial in making Arduino uh, interface. Okay, so I'm not sure if I'm not sure if everything will work as fine. I wish. There we go. Then we have that's for the negative. So practice and practice, and you'll be eventually you'll be getting this. Then the other is for the other input output. Okay, I think I will consume and need this. The white will go for the oh, negative, and red one will go for the positive input. So let's go, and then there we go. I'm gonna have a hold on. Oh, it's not. Let's just check if it is connected. There are some connections that are not working, so you just have to check if it's working. Because if not, you have to make it work. There we go. Then you just have to cut off the excess. There we go. So all that's left is to check if uh, this will work in the Arduino. So without the 12 volts interface or input, so this will only be the ones connected to the Arduino. Let's go ahead to our computer, plug in the codes. All right, so we're here in my computer, and you can see we're ready to plug in the Arduino, which you see on your the other side of the computer. Okay, and we have the codes right here. All right, so this will turn on and off the LCD right here in 1 second, on and off for 1 second. All right, so pin O is your pin output, and then this is the ground, and then um, all right. So let's see now if there's oh, is it too high? Oh, it's no, it's the other way around. So the white should go here. Oh, I missed the color. There you go. I missed the color. That's why. Anyways, it's working. I just missed the color. Then we're gonna try this one. So I know for sure that this one is the positive. This one is the uh, negative. Right? And I want to check it with a power supply, and I hope everything works. And if you heard a sound, then simultaneously clicking on and off, then that's it. Okay, so let's see. So here is our power supply. Wanna plug it in first. Okay, there you go. Hope that everything works. If not, then you have to buy again. So yeah, this one's for the positive. Woo, we pray. Everything's gonna be okay. Woo. Not clicking. Not clicking. Not clicking. Still not clicking. Oh, what's the matter with you? Can I borrow a tester? It's working, but the relay is not working. Hmm. Okay, so something is not right. Maybe this is the same problem with the Arduino earlier. So, So positive, negative. So let's see if something is wrong. Let's check the voltage. What was that? There's a voltage, but it's not clicking. Uh, whew. Okay, let's try to figure it out. So I found out that I have the wrong bits. So this is the uh, um, sinister. Okay, so this is the one that is mistook. It should be the other way around. So you're going to invert the relay for that. You're going to desolder the bits, and then thank goodness if that's the only problem. Yep, that's my fault. Completely my fault. Okay, so because I think there you go. These two are really not connected to one another in any way. So that's it. Ah, common mistake. Yep. Yet I made another mistake. Common, but very wrong. Okay, let's just wait. Okay, let's see if it's not enough. Okay, we can say that you just have to be very careful with the soldering iron. Mm, let's say tool that is getting hot. Wow. Too bad I only have a hand. have the pop. So that's the challenge for this thing. That's why I told you that you just have to review everything before you put it in. So it's my fault. And because that's a common error, because the three pins are ugly. If you have a common relay with a common input, it's a little costly, but let's say she the time. Then let's see if it will come off using wonderful tools. Need this one. We also need this. So to create a hole. The soldering is the worst part. Can clean it a bit. And there you go. So this one, this tool is so as a result, you have to drill another hole, and then that hole will go here. Make sure. Yep. Just have to make sure. Thing will fit. There's a mark. And I forgot what the mark is. The problem is with five pins. You can choose. Let's just put the mark. where okay, we go. Okay, okay, okay. I'm gonna start printing it again. Okay, okay. Then we will do this. So I think afterwards I can share the circuit if it's working. If it's not, I'm going to revise it. And, well, it's finally working. I'm going to share it with you. And go back if we check. I know there are a lot of you out there which are a lot better than me. And let me think let me see what you think. Is this project a waste of time? Let me know in the comment section below. So if you have pro tips, that is very much welcome. Um, that's very much welcome. I know it will help me a lot. Yeah. And just share some love, guys. Why not? Yeah. So we're waiting for the uh, soldering iron to get as hot as I am. Yeah. Okay. Got this. That's an excess. Then this one is the 220 input. So anyway, so if this works, I'm gonna share the link in the description box where you can purchase this thing. I want to sell it, but basically there will be a better appearance because this one is not working. I'm telling you, it's not working. Okay, so same price, different design, but mine is working. Okay, I think I can include this thing here. Yep, this is a genuine design, taken from China. Oh, whoa, whoa, whoa. And then I hope my students will be able to learn things from some right here. Okay, here we go, and there. Okay, so I'm not going to put anything in the inputs. There we go. So final check before we go. Yeah, connected. Not connected. That's why it's not working. Okay, we go back to our um. Yeah, we go back to our computer and see if it's working or not. Okay, so here we go back to our computer. Same code, but a different orientation of the Arduino. Okay. Oh, weird. Okay, so this one is to the negative. So we put it in the ground. One, two, three. Okay, and then oops, this should go here. Okay, and then this one is the positive. Okay, and then the moment of truth. Whew. Uh, it's not. Why? Bakit? So there should be something here, and uh, that would require us to increase input current coming from the relay, but minimal enough. Okay, so there should be a resistor, and um, we need a potentiometer to do that. Okay, so I think I'm gonna put a potentiometer, like say for example 50 ohms, and check. Okay, so yep. Okay, potentiometer. So just to detect um, the preset resistor, um, have to, I do not have a holder. Those who have a good heart, you can send me one. Joke. There's a Gcash link below. Joke. There we go. I think we do not need this here. And then when we were able to find the value of that resistor that we need, we can remove this because it's not good. If somebody turns the knob, the behavior of the circuit will change. Okay. So for the meantime, let's go back to okay again. So negative, positive, AO. Then you see it's working. Okay, so to find the value of the resistance, um, that's not just enough. Okay, you have to set the ohms ohmmeter. So right now the resistance is changing. Okay, but since we know since we know that it doesn't hurt the Arduino. That one is the first part of success. Okay, it doesn't hurt the Arduino, and that's a good thing. There you go. So the clicking sound tells you that it's working, and that concludes our project. It's powered by 12 volts. Okay, or it's actually more than 12 volts. It's not hurting the circuit, and you will see that it's properly working. So I guess is how we make a relay interface to the Arduino.